welcome to this video for Physics Unit 2, and it's all about distance time graphs. Now we're going to start off by looking at a journey of a boy on a bicycle. Now if you imagine this young man is cycling through the park, he travels along for a little while, stops to look at the trees, admire the view and so on, cycles a little bit more, and maybe at the end of his journey catches up with some friends and stops to have a chat with them. Now what you can do with that journey is actually to put some numbers to it and describe the journey in the form of a table. That could look something like this. So we've got time along the top there and distance along the bottom, and you can see at time 0 that's the starting point, and then for 10 seconds he travelled 5 meters, and then the next 10 seconds travelled another 5 meters. Between 20 and 30 is when he stopped, and then from 30 onwards he travelled another 15 meters and then stopped again at 40 for another short while. Okay, so this is a way of showing the journey in a table. Now the next thing you could do is then go on to plot the information on a graph. So you could take your table and plot the individual points. So at time 0 he's travelled no meters, and then 10 seconds later he's travelled 5 meters. After another 10 seconds at 20 he's travelled up to 10 meters, and so on. So you could go through the table plotting all the individual points, and you'd end up with a graph that looks something like this. Okay, so we've got the journey of the cyclist plotted out on a distance time graph, and you can see how the distance and time changes for different regions of the graph. Now it's important that you are able to say what's happening depending on what the graph looks like at the different sections. So I've split it up into A, B, C and D. So if we look at what's going on at A, well, we can see that the distance is gradually increasing as the time increases, and what we say here is that he is travelling at a steady speed. Okay, so he's travelling at a steady speed during point A, and then at point B, a flat region on a distance time graph means that he is still. He's not moving, because as time goes by the distance does not increase any further. If you look from 30 to 40, well, again, just like in section A, you can see that the distance is increasing over time, so he's going at a steady speed again. There is one more important thing you must add for section C. If you look at the line, it's steeper. It has a steeper gradient than at point A, so he's going at a steady speed, but he is going faster. Okay, so the steeper the line on a distance time graph, the faster the object is moving. And then finally at point D, he is still, again, not moving. He's travelled a bigger distance overall, but at this point in time he is still for the final part of the journey. Okay, so this is a distance time graph, and you should be able to say what's happening at the different points on the graph based on what the lines are doing. Okay, so the final thing that I want to do for this is to look at how you calculate the speed from a distance time graph, and this is for the higher tier. So if you're doing the higher tier, this will be useful for you. And the way we can do this is to look at the different sections of the graph and do a little calculations, and we can work out the speed. So firstly we need to know the formula. Speed is equal to distance divided by time. Okay, the distance is in meters and the time is in seconds, and you can do a calculation for the different parts of the graph to work out the speed. So over here, let's work it out for section A. So if speed is distance over time, well, the distance that's been travelled for part A is 10 meters, so he's gone from 0 to 10, so the distance is 10. And the time taken, well, if you read from the bottom, you can see it's 20 seconds to do that. So it's 10 divided by 20, which will give you an answer of 0.5, and the unit for speed is meters per second. So speed for section A is 0.5 meters per second. Now if you're looking at point B, you can work it out in a similar way. The distance travelled from 20 to 30 is from 10 to 10. So in actual fact, for part B, the distance travelled is 0. Time taken is 10 seconds, and 0 over 10 is actually 0. So speed there is 0 meters per second. And if you go back to the previous page, we said that a flat part on the graph means he's not moving, so he's got no speed. And if you look mathematically, you can see that we've shown that the speed is 0 by doing our calculation. Now, we can also work out for section C the speed, and in fact what we're going to do for this part is we're going to do it a slightly different way. We're going to use the gradient method, and this is how it works. So to work out the speed using the gradient method, you take the section of the graph and you just complete a triangle like this, okay? Because we need two important measurements. We need the distance from this point here at the top down to this point, and we need the distance from this point here to this point in the corner here. And this is how we work it out. So we know that speed is distance over time, so we need the distance travelled, and that's this line here. So the distance travelled for part C goes from 10 all the way up to 25. So the distance travelled is 15 meters. Now, what's the amount of time that it took to travel that distance? Well, we again look at the length of this line, and that goes from 30 to 40. So that is 10 meters. And if we do the calculation, we have an answer of 1.5 meters per second. Now, that gives us the speed for region C, which we earlier on said was faster than actually for region A. And if we look at our calculations, we can see that is indeed true, because we've got for region A, we have a distance of 0.5 meters per second, and for region C, it's 1.5 meters per second. So yes, it's a faster speed, and that matches with our idea that the steeper the line, the faster the speed. Okay, so that's a quick overview of distance time graphs, how to calculate speed from them, and I will see you again soon.